Today, I have some laptop power adapters. I wanted to do a direct comparison between the OEM DELL 130W adapter and one of the many replacements on the market. The packaging approach is certainly different on the DELL side of things. I've also seen this style for some Samsung devices. The other is more standard in its cardboard cladding. The main question is whether or not the replacement adapter has the same technology in the box for a little bit of a cheaper price, or if corners were cut to get a product that looks the same but functionally is not the same. I'll be looking at the safety listings and power performance as usual. In this series, I try to answer the question, which power adapter do I want to get? The videos get technical, so hang on, and always ask questions if you don't understand something. The performance is measured and compared to near competitors to see how each one stacks up. If you want to help out the channel, see the links on my webpage or in the description. Patreon is now live, as well as the super button, thanks to my current patrons. Okay, first up is the DELL 130W laptop charger. This was a mistake on my part. I accidentally ordered the non-USB-C version of this adapter. As far as I can tell, the two are also identical with the exception of the USB-C one does have a 5V 1A mode as required for a USB device. But either way, I do have the correct one on the way, so that will be verified in the future. In the meantime, it is a good point of comparison to see how 130W versus 130W clone still does. The adapter has so many plastic peels on every surface. This feels like an older design with all the plastic. Oh wait, it is. The DELL adapter comes with a 3-foot power cord and an 18-gauge power cable and a 3-pin connector. The adapter is connected to the mains through the earth pin with a 1 kilo-ohm resistor. The adapter has a barrel-style plug on the end, in this case the same plug as the HP Blue Tip style. There is no user manual provided. The adapter itself has a DELL and a circle logo. The other side has a lot, to say the least, of labels. I mean, Label City. After looking around for a while, I finally found the UL logo for the Canada and the US, and then the NOM for the Mexico, as well as a 6 in a circle indicating DOE 6 compliance. This also has many other countries. I'm not the expert on all these different places, so if you see your logo, call it out down in the comments. The point is, this thing is well tested and certified to be safe and usable in many different countries. Remember, the barrel jack output of this adapter is earth referenced. This will prevent that tingling feeling with metal-bodied laptops. For the wattage, it is also very reasonably priced. Both this and the USB-C version tend to sit around $60 US. We will look at the value later on. The cord end on the adapter has 2 little white LEDs. I fully expect this DELL adapter to perform within the expectations, and first thing after plugging it in, we can see the idle power consumption is not bad. Less than 0.2 watts means this thing is going to be basically negligible in the electricity bill if it is left in an idle state. This also means that a portion of the adapter is in compliance with the energy efficiency standards. The voltage output from this adapter, being a barrel plug, doesn't have to do any negotiation, so the output is a static 19.5 volts all the time. Okay, time to look at the overall data for this one. The adapter is a strong performer. The power factor correction, or PFC, is something we will talk about in detail in a little while, but for now it is on at the lower wattage, but it does struggle to fully start up. I did notice some coil whine on the DELL in the really low wattage region. I have noticed this on many other DELL adapters as well as HP adapters. As soon as the PFC circuit is fully engaged, this goes away. The overall results are not bad though. For a 130W adapter, this is a fairly strong offering. The efficiency is a little on the lower side, so we will need a point of comparison to see if this is good or bad. Overload is testing when the device safely shuts down when too much power is drawn. This can happen from a short circuit or a misbehaving device. The DELL power adapter tripped on overload at 180 watts. This is pushing it pretty far beyond the 130W limit, but it did shut down. It does require a full unplug and plug to reset the device. Okay, time to get some weights on these adapters. The DELL packaging was nearly non-existent at 12 grams. All plastic though. The power adapter weighed 417 grams. Not bad with all the wires. Now, starting to get into that replacement unit, the packaging weighed 59 grams, and the power adapter weighed 404 grams, nearly identical on the power adapter. In terms of a size comparison, these two adapters look really close to each other. They have a really different plastic finish though. The replacement is a fingerprint magnet, whereas the DELL is a nicer plastic finish and doesn't show things like that. So, the replacement adapter, which is essentially unbranded. There are tons of clones of these online. When you try to find a genuine one, you have to be careful because there are so many cheaper options that pop up for items like this. And I'm just looking for the genuine article. I think this is a larger problem as a whole though. The adapter seems reasonable quality. It comes with a little longer of a power cord at 4 feet. The cord itself lacks any markings on the wire itself and also no safety markings on the ends of the cord. This is a bad start. Oh, I already see where this is going. Get ready for a rant on safety listings. Oh, but it's much worse than that. The adapter has two output modes of operation claimed. It has a 5-volt mode at 1 amp to be able to facilitate USB-C power delivery negotiation. Since this has a USB-C port on the end, it has to do this as the first step to allow the device to ask for the higher voltage output. There aren't many modes on this one, since it is really a purpose-built adapter for one target. I'll check the modes in a bit. There is no connection to earth through the adapter, not unexpected. The user manual is really just extra paper in the box. No specs, not really much of anything in this. A lot of confusing text and a tiny picture that shows a cartoon-like representation. The adapter itself lacks any safety listing. It has a bunch of logos, but none of them mean anything of substance. The unlisted power cord leads into the state of not having a listing on the power adapter itself. The lack of a safety listing compared with the Dell, which seemingly has all of them, is just pathetic. So it must be really cheap, right? It is cheaper, $40, but it isn't like a bargain basement cheap. For the price, I'd expect at least some kind of listing. The power cord to the USB-C plug is the same in that it has the LED on each side to show the power is on. This does have the 6 in a circle logo, so let's plug it in and check that out. I have no idea what to expect. The power adapter has extremely low idle power consumption. This is either a good thing or something related to cost cutting. I bet I know which one. Can you guess? This is a very good number though. This also means this portion of the adapter is in compliance with energy efficiency standards, even though I doubt this was actually checked. The output voltage from this adapter is either 5 volts as idle, and it has an 18 volt and a 20 volt mode for output voltages, which is a little unusual and certainly not in compliance with the USB power delivery specification at 18 volts. Once the power is brought up, we can see this isn't turning on power factor correction. The number is staying low. Let's push this up higher and see if the performance changes. All the way up to full load, and nope. This device has no power factor correction in a 130 watt class power supply. This matters. So a little cost saving and cutting of every corner to make a profit means you pay. Okay, time to look at the overall data for this one. This adapter is actually good in the idle power consumption, but everywhere else it's flat out bad. The power factor correction, or PFC, is non-existent in this device. This hurts the numbers. I am measuring the power directly at the plug, so this does not take into account additional losses lacking this correction would have when you're using it with a regular household situation. So this adapter is even worse than it appears. The efficiency is surprisingly low for a power adapter like this. I'm only really seeing one positive point here: idle. Okay, time to check out the overload on this adapter. The replacement adapter tripped on overload at 145 watts. This is a safe limit. This adapter goes into a hiccup mode when an overload is present, but it does reset without being unplugged. The power factor correction is a technique to consume AC power as efficiently as possible. The higher the power factor, the lower the comparable current, and therefore the lower the loss in wires and transformers that supply your power. The goal is to have all the waves look like the same shape as the yellow line, a sine wave. The replacement adapter obviously isn't getting much correction done here. It isn't even close. The Dell adapter, when powered on, looks great at only 20 watts, a pretty typical static load for a lot of high-powered laptops doing nothing. The other adapter looks bad anywhere by comparison. Comparing power factors and wave shapes at full load, and we can see that the replacement adapter looks worse in every metric. The efficiency is even worse without a power factor correction circuit, so this is really showing how poorly designed this one is versus the much older but much more refined circuit in the Dell adapter. Let's talk about the voltages and currents on the USB power delivery specification. If these adapters decide to go with USB-C as the output port, they should be complying with the USB-C power delivery specification. They don't. I know it is an option, but it would be preferable to have them be more universal. If in Dell or replacement form, these would not comply because they can deliver more current than the USB-C connector is rated for. These are 5 amp connectors, and they allow them to pass 6.5 amps, which means they are going to get warm and waste more power. Not that the tiny barrel plug is efficient here either, but there are better ways of doing things now. By pushing the voltage up and taking advantage of an extended power range, you can keep the current low and therefore lower losses and more efficient in power delivery to devices. This is a win-win. I hope more laptops in the future adopt these power modes. There are plenty of 140 watt single power adapters on the market now too. Okay, time to compare the data with a bunch of other adapters. I pulled in random adapters from some laptops and a few USB-C adapters. When comparing the idle data with others, the replacement adapter takes the win here, but both are really good performers. Being this low on idle represents active care to make sure the power supply is on target. Both power adapters also had relatively clean power in the idle state too, so the power quality scores aren't bad on either. The idle graph, the story is the same. The Dell is thoroughly in the middle. Both of these are well within the power requirements for the energy energy efficiency standards though. When comparing the overall data with other adapters, the story starts to change in favor of the Dell. In comparison with other laptop adapters, this is right on target, right in the middle. A dedicated USB-C power brick can be more efficient still, but this is showing good performance for these power supplies. The replacement is trash. Even compared with the lower wattage adapters, this is worse. On the average power consumption graph, the replacement adapters on the bottom for power quality score. It is truly a terrible performance for a power adapter in this power range. Then there's the lack of safety listings. Let's talk about value. So is the replacement adapter a better value? Yes, it is, on paper, and ignoring all the other statistics, it is cheaper for the same number of watts. So, case closed, buy it. No, do not buy it. This is totally disregarding generally accepted safety practices, has no listings at all, and totally lacking any power factor correction for a 130 watt adapter means this is built very cheaply and doesn't have the performance to back up that value proposition. I would steer far clear of this one. You notice the value proposition on all the other adapters for laptops is basically in line with each other. This is for a reason. It takes a little money to make a better product, so not rock bottom, but still reasonable value. The replacement looks too good to be true. Okay, that's about it. I hope you enjoyed a little discussion on some laptop power bricks. I wish I had the correct one to compare to, but I will soon enough. I'll probably do a post or short or both, updating how the actual Dell 130 watt USB-C adapter ended up in comparison. These two adapters are polar opposites. The replacement is cheaper, but not that cheap. Although it does represent very good value, it is unsafe garbage and it'll cost you in the long run because it will either break or the energy cost will catch up to the poor performance. Or if you spend a little more, get the OEM Dell adapter and be a little more happy. These things last a long time. Obviously, there's always going to be a failure of any power supply in time, but I feel more confident in the Dell OEM adapter, and I think I will put this one to good use in some other projects. Okay, time to apply some stickers. These are tested and on the database, so you can take a look at how they stack up. These two adapters span a wide range of power quality again. One is the Nightmare Fuel, and the other is a pretty nice piece of kit. I'd trust one of these and run far away from the other. I will have some affiliate links in the description to help out the channel. Thanks for watching. Next week, I have another video on the smaller side of power adapters. I have several Anker lower wattage devices like the new 313, 323, and a PowerPort Slim, and a Ugreen competitor. Check my website for upcoming videos. There's a schedule of release dates. I have many more of these adapters to get through, so many more videos in the future. Goodbye.